Have you ever wondered why sugar seems to dissolve faster in hot water but takes longer in cold water? Or why some sugars dissolve more easily than others while some just sit at the bottom for a while? These little things often go unnoticed, yet they hold fascinating scientific explanations. In our daily lives, we use different types of sugar: granulated sugar for sweet tea, rock sugar for herbal drinks, palm sugar for traditional dishes, and powdered sugar for baking. Each has its own unique shape, particle size, and composition. But what happens if we test how fast each one dissolves in water at various temperatures? In this science project, I explore how temperature affects the dissolution process of four common sugars: rock sugar, granulated sugar, palm sugar, and powdered sugar, by measuring the time it takes for each to completely dissolve in cold, room temperature, warm, and hot water. I analyze the role of kinetic energy, particle surface area, and the interaction between solute and solvent. This experiment introduces us to concepts like solubility, molecular motion, and surface area, but in a way that feels close to home. It proves that science isn't always about labs and expensive tools. Sometimes it's just about being curious while watching sugar melt away in a cup of water. And the best part? This whole project can be done in a single day using simple kitchen tools and ingredients. It's fun, visual, rich with data, and perfect for learning through doing. After all, science doesn't always come from textbooks, it comes from your own kitchen, one spoon of sugar at a time. This graph shows how water temperature affects the dissolution type of four types of sugar: granulated, powder, rock, and brown sugar. It is clear that higher temperatures lead to faster dissolution. Powder sugar consistently dissolves the fastest, while rock sugar is the slowest, especially at lower temperatures. For example, at 12 degrees Celsius, rock sugar takes 304 seconds to dissolve, while powder sugar only takes 82 seconds. At 100 degrees Celsius, powder sugar dissolves in just 5 seconds, and rock sugar in 87 seconds. The pattern shows that temperature increases the motion of water particles, speeding up dissolution. The type of sugar also matters. Smaller particles dissolve faster. This bar chart compares the dissolution times of four types of sugar at three different temperatures: 12 degrees Celsius or cold, 70 degrees Celsius or hot, and 100 degrees Celsius or boiling. It clearly shows that all sugars dissolve more slowly at lower temperatures, and their dissolution time drops significantly as the temperature increases. Powdered sugar always dissolves the fastest, needing only 5 seconds at 100 degrees Celsius. On the other hand, rock sugar takes the longest across all temperatures, although it still becomes faster, from 340 seconds at 12 degrees Celsius to 87 seconds at 100 degrees Celsius. This chart highlights the strong influence of both temperature and sugar type on the dissolution rate, with temperature playing a particularly dominant role. This radar chart compares the dissolution rates of four types of sugar. The data has been normalized to display relative patterns more clearly. Powdered sugar consistently shows the highest dissolution rate all temperatures, meaning it dissolves the fastest. In contrast, rock sugar has the slowest rate, especially at colder temperatures. This chart provides a quick visual comparison of how each sugar performs under varying heat conditions, reinforcing the idea that both temperature and sugar structure significantly influence the dissolution process. Based on the experimental results and the visual data from the chart, It is clear that water temperature has a significant impact on the speed at which sugar dissolves. As the temperature increases, the dissolution time decreases for all sugar types. This is because higher temperatures increases the kinetic energy of water molecules, making them move faster and interact more effectively with the sugar particles. In addition to temperature, the type of sugar plays a crucial role. Powdered sugar, with its fine particles and greater surface area, dissolves the fastest across all temperatures. In contrast, rock sugar, due to its dense and large crystal structure, takes the longest to dissolve, even in hot water. The combination of temperature and physical characteristic determines the overall dissolution rate through the use of line, bar, and radar charts. These patterns become visually clear and scientifically insightful. Through the use of line, bar, and radar charts, these patterns become visually clear and scientifically insightful. This experiment demonstrates that concepts like solubility, surface area, and molecular motion can be observed and understood through everyday activities in the kitchen. With a simple yet scientific approach, this project not only deepens our understanding of chemistry, but also proves that curiosity is the starting point of discovery, even when it begins with just a cup of water and a spoonful of sugar.